Hi, my name is Vitalie. I'm working as a DevOps engineer at Luxoft. The subject that we will cover today is Kubernetes with KubeVirt and Harvester. This is an overview of these tools. Also, I will show how you can integrate a legacy VM into Kubernetes. Let's get started. These are the topics that we will cover. What is KubeVirt? Why do we need KubeVirt? How a KubeVirt VM is launched inside the Kubernetes. Then we will speak about how to import a container inside Kubernetes pod. Then we will speak about how can you migrate all your legacy VMs into Kubernetes. Also, we will speak about other use cases for what do you need or you can use, where can you use KubeVirt. We will cover Harvester, architecture, a bit of dashboard, and a use case how you can install Windows 11 on Harvester. Also, other tools like Forklift and Coriolis, we will just mention them as tools that you can use to migrate all your workloads, all your existing workloads to KubeVirt. Let's get started. What is KubeVirt? Why do you need it? You need KubeVirt because there are a lot of legacy applications that cannot be rewritten. Yeah, you need a lot of resources to rewrite that code. So then you are stuck with some new code and you are stuck with some old code that you are having and you don't know how to migrate your old code to Kubernetes. So you have new pods, new fine code that is running already in pods, and you will have the possibility to have all your VMs and to jump them into Kubernetes. So the problem is that you have old VM workloads on some VM platform, and then you also have Kubernetes that is running new code and microservices and all is nice here. But you still need a team to manage both. You need logging, you need metrics, you need monitoring, you need knowledge about all this stuff. So it's getting a bit complicated. Why not to simplify it? So KubeVirt will help you to have a unified solution like Kubernetes, a unified orchestrator that will help you to manage all these resources. You will have unified monitoring like Grafana or Prometheus, and you will have one thing where everything will be inside. And why KubeVirt? KubeVirt will do a convergence of all these two workflows. So you will have only one workflow. And how do you manage virtual machines inside Kubernetes? You use the same tools as for your pods. Here we are showing a VM launch flow. So you basically give a YAML file to kubectl. kubectl will take this and will pass this via API server to virt controller. Virt controller will create a pod for VM process and will launch it inside the pod. Then virt handler will launch a KVM and KML process that will take the disk image from a PVC and will start up that VM for you. So let's speak about storage. Storage in KubeVirt, it's done via PVC. So you mount a volume via PVC, and for that you have a containerized data importer tool, and that CDI tool will create a volume, a data volume that actually will create a PVC for you. How do you create a virtual machine? So you download a manifest file, you apply that manifest file, then to start a virtual machine, you patch it, you use kubectl patch, and you patch that spec to running true or patch that spec to running false if you want to stop it. Okay, let's cover more about how you import that disk image to your virtual machine that's inside the pod. So you use that tool, and that tool it's introducing data volumes. So it will create a data volume that will point either to a registry, either to a HTTP website, or you can actually create also images from your local disk images. Let's see how to do that. So for example, you have that YAML definition to create that data volume. This is a data volume to create a Fedora machine. This one is pointing to a remote source, to a HTTP, to a URL. So from this URL, it will get the image. It will create from that data volume, it will create a PVC, and then you can point into, when you create a virtual machine spec, you can point that to that PVC that it's created. Also here I have an example. You can upload a local image. Yeah, for example, your image is in here, images Fedora, and then with the virtctl, it's a tool that you can install as a plugin also into Kubernetes. You can upload this image to a data volume, and then when you will list PVCs, you will have it listed as PVCs. So here we have a YAML spec for the full VM. So what is important part here is a volume name disk and persistent volume claim that it's Fedora, and that Fedora volume claim we just created here. Yeah, here we created, and also as a source you can use an S3 bit bucket, or you can use an registry like Docker, and also you can create a data volume using this tool virtctl from a local image. So that's how you create actually a Fedora virtual machine using that specific Fedora image. Let's go further. How do you migrate any legacy OS? So for example, if you have a Windows XP and you want to migrate it to Kubernetes, you can boot it with a live Linux, then you HDD that image to that disk. You HDD using this command to an image, then you convert that image to a QCOD2 format, and then you use virtctl tool to upload that image into a data volume, and then you use that data volume name to create a virtual machine. For Harvester, there is a nice GUI that helps us to speed up that process. It's a bit simpler. A use case for KubeVirt will be to use it as a GitLab runner or to use it as a Jenkins agent. So it's very similar. So you build an image as I exposed before. You convert it to Kemu. You have all your tools inside, like Nugget, like .NET, or like any other tools that you need to build your software, to run your pipeline. Then you push that image to a Docker registry. Then inside Kubernetes, you have those YAML files that you create, those data volume that are created by pulling the Docker image inside Kubernetes, and then you can run those pods. And with the Helm chart, you can deploy those runners into Kubernetes, and you can have all this monitored by Prometheus, and you can see that nicely in Grafana. Another use case is to use the KubeVirt for AI, for big data, for deep learning, and to use it for these things you need GPU. And to access NVIDIA GPU, NVIDIA created a plugin for it. So when you install this plugin on your Metal server, you will have access to those cards from inside KubeVirt. Okay, let's speak about Harvester. As you observed, there is a bit of YAML files to edit to have KubeVirt running. So a better tool to have that is Harvester. You will have KubeVirt installed. You will also have a Rancher Kubernetes server that will use Longhorn storage, and all this it's installed on the SUSE Linux. You install it as a normal Linux. You have an ISO file and you install it on a bare metal. You install first node and then you can join other nodes that will create your cluster, your Harvester cluster. And why Harvester and not other HCI solutions? So Harvester is 100% open source. It allows you to see everything in one place. So from the same place you can see your pods, you can see your VMs, and also it's not locked to a specific hardware. Another tool that Harvester uses is it's Multus. It's Multus CNI plugin, and this one enables multiple network interfaces to be attached to VMs and provide VLANs. Also, it helps you to provide a DHCP server, so all these VMs will be able to get their IPs, and you can have some VMs into VLAN 1 and 2 and so on. So you will have nice networking capabilities using Multus. Yes, sure, you can do that without Harvester, but it's easier here. Here's the Harvester dashboard. You also can have other plugins and have everything in one place. You can have monitoring, Grafana, everything in one place. Now we will show how to run Windows 11 on Harvester. So what you need to download this ISO images. Then you have to create a virtual machine. First you will create an image that will point to that ISO files. Yeah, you creating a boot drive, and that boot drive actually will point to the image that you downloaded. And then you will create additional CD-ROM that you will attach, and on that CD-ROM you will have the drivers that you need. Actually, Harvester comes with Virtue drivers, but those are not good since they do not support Windows 11. So you have to have that ISO that I have on my previous slide. Also, when you try to install it, will tell you that your PC does not meet the minimum requirement to install Windows 11. So you have to edit a bit of registries. So you will press Shift. Yeah, you will have Shift F10, and then you will edit this specific registry key. You will change all these D words to 1, bypass TMP check, bypass secure boot, and bypass RAM check. And after that, you can exit from here and and restart the Windows setup, and you will have it running. You will get it running. Also, before installing, you will need to load drivers, and you will load drivers, and you will point to that CD-ROM with the Virtue driver that we downloaded earlier. Another tools to use for migrating is one of them is Forklift. So with Forklift, you will be able to migrate from VMware, from OVirt, from OpenStack to KubeVirt. And also another tool is Coriolis. With Coriolis, you can migrate from all these cloud endpoints to KubeVirt. So the both way migration is possible. So you can migrate either from VMware to AWS, or from Azure to KubeVirt, or from Oracle to KubeVirt, or vice versa. Hi, in this part we will have some demo where we will install a Rancher server, Rancher Kubernetes cluster. We will use this Git repos. Um, For the demo to work, yeah, you see here you have the directories that you get after the git checkout. Here is a README. Basically, what you have to do is to edit this host init files. I have all these IPs, so this will be kind of masters, and then this will be the agents where the workloads will run. We will install this Kubernetes cluster, and then on top of it we will install Rancher using these commands, and after that we will install KubeVirt on top of it, and then we will run a VM. We will deploy Fedora VM. First we will deploy VM without PVC, and then we will do one with the PVC. We will import a raw QCow 2 image, and then we will run that VM. Let's get started. So for to install this cluster, we will use this site YAML. First, you have to add the IPs of your cluster. Then we will use that site YAML file that will call these roles, these YAML roles. Yeah, let's get this started. Yeah, sure, you need this Ansible CFG to point to your inventory file. You need these settings, but all the stuff it's in a README file, so you can. After installing the Kubernetes server, um, on top of these nodes, I will install a Rancher web interface. I already installed it. It's this one is the configuration I used. First, you have to install certification manager. Uh, so you have all these pods and deployments that will take care of SSL certificates. Then I installed using this Helm chart. I installed Rancher, and if we are looking into this namespace, we will see all the Rancher components. There is a replica set, deployments, and Rancher webhook and Rancher service. So this is a Rancher web interface. Uh, After that, we need to install MetalLB to be able to expose our services, because you need to expose KubeVirt proxy service that will import our QCow2 image into KubeVirt. Let's go here. We have a nice web interface where you can install stuff, and we will install MetalLB, and then we will configure it. Yeah, let's install it. Yeah, this is the command that it's running behind, and we have a success here. Then after installing MetaLB, we will have to configure it, and we will configure it using this one, and actually not only this one, but this one. Okay, so first we are assigning this address pool, and then we create this L2 advertisement where we link it with the first pool. So now we have MetaLB, and any service that we will set to load balancer will get an IP address. And let's actually expose one of our services. But first we have to install KubeVirt. Yeah, let's install KubeVirt. Okay, you have a quick start cloud. I think I have it here. You copy this one. Okay. So you have this operator, this replica. Okay, you can patch it. Still not found. Second, we need to install CR. So it's deploying. After it will deploy, we will need this tool, virtctl, but I think we have it. Yeah, we have it here. Okay, let's see if it deployed. Oh, I installed this virtctl, and now we will need to install CDI, containerized data importer. Yeah, let's install this one. Okay, and now we have to expose that that service into CDI namespace. Let's see what it installed there. Yeah, still some stuff to install here. This the service that we will have to expose. Yeah, you can see here it has no external IP, and let's expose it. Okay, it looks like it exposed that service, and now we can we can try and import for a disk volume. So basically, this is our Fedora QCOW2 format, QCOW2 image, and we will try to import it. Okay, we're getting an warning that a storage class Longhorn is not found, so we have to install it. we have this Rancher web interface and we will install it there. It's a bit slow. Let's see what we want to do here is to have this this virtual machine created, and this virtual machine has a volume that is pointing to a persistent volume claim. So we have to create that PVC, and the CDI will help us to do that. That's why we needed to export it, and we need to install Longhorn as a storage class, so we can use it as a backend for persistent storage. Okay, it keeps loading. It's a bit slow today. Okay. Okay, needs to create everything that is here. Creating containers on each node. Okay, all this stuff is responsible for Longhorn. And okay, we are having success. So a storage class named Longhorn was created, and now we can upload our image to a disk volume that will automatically be linked with this PVC, and then we will be able to create our virtual machine. So any disk image, anything that you want to import to Kubernetes, you need to make a QCOW to image. So basically you do a DD, then you use Camo to convert it, and then you can upload it to a DV. Another method is to place it on a web server and or on a Docker registry. Okay, you can see it starts to upload data, and it's complaining that it has no root to host. Let's see why. So 163.100. Okay, our IP is wrong. Okay. Yeah, that was the problem, because it is exposed at this IP. A couple of moments and it will create that DV. Okay, so DV is created, and now we can create our VM. This is the command to create it. Okay, so container is creating. Let's connect to it. Now you can see this virtual machine booting. And that's it. As you can see, we got our cloud init running, and actually I think it added my key. Yeah, this is my key that is added. Let's see if we can log in. Okay, so we have it. It's Fedora Linux inside Kubernetes. MySQL is it's coming online. We are creating this for you to see how how you can expose any service from inside VMs. You can expose them via Istio or via Multus or via any networking solution that is working for pods. It will work for KubeVirt too. So if we will delete these pods, then it will recreate them with the Istio injection enabled. Yeah, you see, VMI zeros Istio. This one is terminating and it's initializing with two containers. One of these containers is Istio. So we will see how we can have one single unified monitoring for our VMs and for our pods in the same place. We are running for 8 hours now, and I want to show some graphs. You can see here CPU, memory, network traffic. This is for Istio VM. Also, I have it for VM2, the Fedora one. Also, I have it for MySQL. So MySQL is a simple pod that is running inside Kubernetes, and these are two virtual machines. Also, there are some other Grafana graphs regarding this nodes, API server. Yeah, all this good stuff, you can have it in a Rancher, and there you can install all of this. Also, you can have a Jaeger on this virtual machine. All the requests, all the tags, IPs, and so on. So this is all in this presentation. If you have any question, just ask on the Slack channel. Thank you.